Hello everyone. At the end of this particular session, we will be able to understand following points. Different cases of image formation in concave and convex mirror is what we are going to discuss in today's session. Okay, so let's start our discussion with the first case of the concave mirror. As you can see here, object is at infinite. Okay, object is situated far away from the concave mirror. Now you know that infinite is basically a relative term. Okay, and it is as compared to the curvature of the spherical mirror. Now infinite is basically with respect to the curvature of the mirror. This distance of the object is actually a great distance, and that's why we are neglecting that particular distance. Okay, and we are neglecting that particular curvature, and we are saying that object is actually situated at infinity. Once again, infinity is a relative term. So as compared to the curvature of the mirror, the object is situated at infinite, that is at a great distance. Now light rays incident parallel to principal axis. After getting reflected from the mirror, it passes through focus. And then here also the same thing happens. So light rays which are getting reflected, which incident parallel to the principal axis, after getting reflected from the surface of the mirror, they are passing through focus. Okay, and because they are passing through focus, you can see that their point of intersection is here, and the image would be formed at focus. Okay, image is formed at focus. What type of image is it? Because there is actual intersection of light rays taking place here, that's why it's a real image. It's an inverted image, and it's a highly diminished image. I hope that this is clear to you. Let us now discuss the next case. In the next case, you will see that when the object is kept beyond center of curvature. So what basically we are doing, we are trying to bring the object towards the mirror. हम object को mirror की ओर लेकर आ रहे हैं. So as we are bringing the object towards the mirror and we are keeping it here, this is the center of curvature, this is focus, and this is pole. So when we are keeping it beyond the center of curvature, light ray incident parallel to principal axis, you know that after getting reflected, it passes through focus. And light ray which passes through center of curvature, as it is shown here, light ray which passes through center of curvature, then it retraces its original path. Okay, and as they are intersecting at this point, we can draw a perpendicular here on the principal axis, and this is the image which is formed. Now what type of image is it? This image is real, inverted, and diminished. Of course, real image because there is real actual intersection of light rays. Okay, it's inverted as because it is inverted, you can see, and diminished because its size is height of the image is lesser than height of the object. So this is the case when the object is kept beyond center of curvature. Let's see the next case, and next case is when the object is at center of curvature. So when the object is kept at center of curvature, you can see light ray incident parallel to principal axis. After getting reflected, according to the rule, after getting reflected, it passes through focus. And light ray which passes through focus after getting reflected becomes parallel to principal axis. Now these two light rays are intersecting here. If we draw perpendicular here on the principal axis, you will get the image here. Okay, what here means at the center of curvature. So image is formed at center of curvature. Of course, it's a real image, it's an inverted image, and same size image. Same size means height of the image is equal to height of the object. So its size is equal to the size of the object. So these are the cases. This is the third case of the image formation in case of concave mirror. Let's see the next case. Here now the object is kept between C and F. You can see this point is C. Sorry, this point is C, and this point is C. Just a minute, I'll just erase this previous one. This point is C, and you can see that this point is F, focus. Now light ray, this is the object which is kept here. So light ray incident parallel to principal axis after reflection passes through focus, and light ray which passes through focus after getting reflected, what happens that it becomes parallel to principal axis. Okay, and here they are getting intersected here. If we draw a perpendicular, you will see that this is the position of the image. Image is formed beyond C. It's a real, inverted, and of course a magnified image. Okay, Let's see the next case. Now what we are doing, we'll be keeping it at focus. So object is now kept at focus here in this particular case. When object is kept at focus, what will happen, that if we follow the rules for the image formation, light ray incident parallel to principal axis after getting reflected from the mirror becomes parallel to, sorry, it passes through focus. Light ray incident parallel to principal axis after getting reflected passes through focus, and light ray which is coming from the center of curvature after getting reflected, it retraces its original path. Okay, so as you can see that these light rays are actually parallel, so they are supposed to meet at infinite. Okay, and the image which is formed is real inverted, and of course it is highly magnified image. In this case, highly magnified image is formed. Now up till now, all the cases which we discussed, in that we actually obtained real images only. However, there is a case, there is only one case in concave mirror when we will get an erect and virtual image. Let us talk about this particular case. Suppose that object, this is the focus point. Okay, this is the focus point, and this is pole, and object is kept between pole and focus. If the object is kept between pole and focus, you see light ray incident parallel to principal axis after getting reflected from the mirror becomes it passes through focus, and light ray which is coming from the center of curvature after getting reflected retraces its original path. If we extend these light rays forward, you will find that these light rays are actually appearing to come from this point. Okay, basically what happens here is that the gap between the light rays, it keeps on increasing, so they are not supposed to actually meet here. Okay, and that's why we have to extend these light rays back to get the image. Now this is the on, so you can say that the image formed is behind the mirror. Of course it's a virtual, erect and magnified image. So this is the only case, and that's why this is a very special case in concave mirror, when the image formed is virtual, erect and magnified. This is the only case when the image formed in concave mirror is virtual and erect. I hope that this is clear to you. Thank you.